Okay, so continuing from the previous lecture, over here we have ended, and we are talking about how to AND devices they are communicating, right? So in this example, this is a client server model, right? So in this client server model, uh, this is one and this is another AND, right? And we are talking about AND to AND communication, right? Over here. And this is also known as client server model. Try to understand this thing, right? So in this client and server model, where we are using some services such as HTTP or HTTPS or telnet or FTP, right? These are the services which are making use of this connection oriented services, right? These are the connection oriented services. In that, we have these six primitives, right? What are those? That is, request is there, then response is there, then data exchange, then reply, and then disconnection, right? So these are there, and this is how it will happen. And one more thing that we understood in this class, in the previous class, that the communication basically take place from one process to another process. So that's why it is known as process to process communication also, right? This is one process which is running over here, right? That could be HTTP. That is one daemon service, right? HTTPD. D stands for daemon, right? So one application which is running in a background, right, which is communicating with another service, right, over here, or a process which is running on the remote system, right? So, or you can say we can make use of RPC over here. What is the full form of RPC? Remote procedure call. This client server model is also making use of this RPC connections, right? So we will talk about what is RPC in the later slide when it will come. But yes, just remember the keyword. What is RPC? Remote procedure call. Like over here, a random number will be generated, port number is generated, and then it will establish a connection with a well-known port number for that service, right? So with that port number, like HTTP, we having 80, and with the IP address, we could able to make a socket, and then we could able to connect, right? Just like we have a socket at home, that electrical socket through which we connect. Similarly, here the combination of IP address and port number will make a socket, and this socket is basically allow us to connect with these two systems. So over here also we having an IP address and port number, right? So IP address plus port number will allow us to connect with these two different socket, which is nothing but a process. So that's why it is also known as process to process communication. And where it will happen? It is happen in a transport layer. We will, I will show you this thing when we will into this particular. Now, this is the previous class takeaway, and we have understood that how this thing is happening, right? So coming to the OSI models, right? That layers. If we talk, then we are talking about the layers, right? Because each layer has some work to do. They have some responsibility, right? And we have understood also that if a layer is there, then it is providing a service to the lower layer and the upper layer, right? So that's why it is known. You can see bidirectional over here, both direction. So this layer is again providing services to the lower layer and the upper layer, right? And so on. So it reduces the complexity. The idea of introducing the concept of layer is to divide the workload or to divide the task among this layer, right? And all layer will take care of their work accordingly. So it could, and in future, it is very easy to even identify the problem where and in which layer it is, right? So you can see that this is a relationship basically which is talking about between the services to the protocol. So you can see this is the protocol in that layer, like TCP protocol or UDP protocol. TCP, so TCP is there. If it is UDP, so UDP is communicating with another. So that is one protocol to protocol. and that layer, you can see this protocol is providing services, right, in a sense, to the upper layer and to the lower layer. So that's why there is a close relationship between these services and the protocol, right? Now we will see that these are some of the design issues when we are planning for that layers, right? So this is clear in our mind that we cannot able to go with a single layer, because every module will be in that, and the complexity will be very high, right? Then again, it is very difficult to identify the problem if it exists, and lots of issues are there. So the solution for that is to divide the task into all these different layers. So how many layers need to be there? For that, what this organization is there, that is OSI ISO model, right? This one organization is there who has decided that, okay, we have 7 layers, right? So in this model we have 7 layers, right? And then when designing this thing, they identified that they will face these issues. So those issues we are talking about. One is addressing whom I am going to talk, and how to identify or send a receiver. It's just like when you want to send a message to your friend. So you don't you not only write a message, you also include some additional information, such as address, such as name of the receiver. Similarly, when we are sending a message to someone in a network, what we need? We need a sender, we need a receiver. So that's what it is required. And how we are going to identify them? So for that, we need some addressing scheme, because that system need to be identified uniquely. If that could not be done, then there will be a false or a wrong delivery of packet, wrong delivery of messages, which would not be accepted, right? So आपका message अगर if it get delivered to your neighbor, then the meaning of sending that message will be useless, right? All that, there will be a huge chaos all around, right? We don't want that thing. So that is what the first thing that come in picture when we are designing the layer, that how we are going to perform addressing. So you have seen a network layer was designed for this purpose, the third layer, and device which is working for this is router, right? And your switch, right? They are working on this. The second thing is, the issue is that how data is going to transfer. It should be going from one side or in one angle only, right? You can say in one direction only, right? Like if we are talking about a radio communication, so from that terminal, right, what we are getting signals, and all other are receivers. So the communication over here is known as simplex. This is one way channel. So that is that we have to decide when we are going with this communication, right? Or it should be half duplex, that transmission could be possible on both sides, but not at the same time. So that's why it is half duplex. Just try to understand this part, right? Communication could be done in both direction. Over here, the sender and receiver, and over here also it could become a receiver, and this could become a sender. So this is a second type where two-way communication could be possible, but not at the same time, right? Then the third one is full duplex. Full duplex means where both could be done, right, at the same time, right? Like we are using phone, mobile devices, right? In this, we have an example of walkie-talkies there, right? So that is there. So we need some rules for data transfer. That over here, the rule says that in one direction, over here in both direction, but not at the same time. Then both direction, but at the same time. But what it does, it divides the bandwidth. One is required for the receiver, one is required for the sender. So half the bandwidth get halved for upload and for download, right? In the both direction, if you want to do the communication. So all that factors will come in this particular rules for data transfer, right? Then, as we understood, in some cases that the data is being divided into small chunks. So once the data is divided into small chunks, because we have that tunnel in which we are sending our data, that through that medium, right? And it has some size it can hold. Suppose 500 mu, right? Or something 1400 or something. So message unit it could able to hold. And if our data size is more 10 times more than this 500 1500 mu, then it could not be possible that we can send the entire data. Then what we will do? We will not able to send. No, it should not be like that. Then there should be alternate method. Then what we will do? We will divide the data into
ये अपने आप को इंगेज बता रहे हैं। 3 तारीख को स्किल टेस्ट है, उसके बाद सब इंस्पेक्टर का आपका है 8/11 को यानी कि नवंबर को।
Sir, your mic is off.
hello. Now I'm audible.
Yes, sir.
Okay. So what I was saying is that let me explain this one, the third point, right? What I was saying is that we need to reconstructing the message. Why it is needed? Because we know that that large messages could not able to delivered in that fixed length tunnel, right? Which has some limit, right? So now this is our message one. We have numbered them in a sense that we could able to recognize in the receiving end, right? This is a sequence. Otherwise, what we will do in the receiving end, we will receive a wrong sequence, and out of that we will construct a wrong original message. So that make no sense, right? So for that reason, what we are saying that we need a method in which we can able to reconstruct the segregated message, or you can say segmented messages. This is segmented into small chunks, right? And then they are allowed to move in a network, right, through any path. And there may be a case that message one is arrived, message 2 has arrived earlier than message 1, right? So now if we now not giving a sequence number, then it is very difficult to distinguish between them, right? So what is needed? We need some method in which we could able to recognize the sequence. So what we will do, we will number them, and that is known as segmentation, right? So with the help of some flag bits, we will generate some flag bits which will talk about the end of message. Like we have flag 0 and flag 1, right? In that sequence, we will come to know that more messages of same type is yet to be delivered in that manner. Receiver will come to know with that flag entities, right? And the segment number, the same segment number in that sequence will explain that, okay, this is the data of this particular segment, right? And where the flag will decide, and flag will tell us that okay, more packets yet to be arrived of this segment. So we cannot compile that data till now, right? So compilation, when to start the compilation, that is very important, right? So there is a need of reconstructing the messages. So these are the design issues, how we are going to achieve this part when we are talking about. So this task need to be given to any of the layer, that 7 layer we are talking about, right? So similarly, error correction is there also. Now during transmission, one can understand that due to interference or due to attenuation or because of collision, there could be a chance that message get corrupted, right? Now that corrupted message would not be accepted. Now what we can do, we have to get a duplicate copy of same message from the sender again. So in that sense, we need some mechanism where we will inform the sender that resend the copy of this message, because this message you have sent is not received me as it was original, because in between, during transmission, because of interference of electromagnetic waves, or because of collision, or might be intruder, or some hacker has changed the original bit values, which is not getting correct or calculated through that checksum, right? So what is needed? There is a signal that receiver will send back to the sender that this message is having some problem, and whatever you are claiming and whatever is there in header and checksum is not getting match up, right? So it is something like fishy, and we need to make a you need to make a retransmission of that message. So we need a method for doing this also, right? So that's why we are talking about this error control mechanism, and this task need to be delivered, right? This task need to be delivered or given to some of the layer, any of the layer. So as we can see, this error control is there in your data link layer, and even in some other layer also, that is we will see that in transport layer also, right? Where the last problem, you can see the design issue which talk about large messages, right? So large messages could only be transferred when we will divide into small chunks. So we will cut them down into some small chunks, right? And then we will transfer them one by one through that tunnel, right? Now the problem is how we could identify in the receiving end that which message will layer after next lecture, next message. So in that way, what is needed? We need a sequence. So what we will do when we are dividing them, we will provide a sequence number, and on receiving, on the arrival, they can reach through any sequence. 7 can reach earlier than 1, 6 can reach anyone. So in that sequence number, we could easily able to identify that which message will come at which position, and we can form it into a original message, right? So this was the challenges of these design issues when we are talking about layer structure, right? Yes, class, you have to mark your attendance by writing present in the chat box. And okay, so we will start with the next slide which talk about the models, right? So this transmission of message from one client to the server or from one sender to the receiver required some model, right, or method in which we have understood that layer method, right? So, and that layer architecture is known as this reference model, in which we have first one is known as OSI reference model, right? Then second, which we are using in today world, that is TCP IP model, right? So today we will talk about these two lay models, and then we will have a comparison of these two models, right? So this is how it look like. You can see, I hope you can see the slide, right? So these are the 7 layers you can see, and this is one first layer, this is your second layer, this is third layer, fourth, and so on. And each layer is discussed in each unit, as you will see the syllabus, right? So we will soon, then when we will complete this chapter, you will see that we will start from the physical layer, then the data link layer. Each unit will be covered in this manner, right? So this is the very important, most important, or you can see the core part of our networking, right? So this is your OSI ISO model, which have 7 layers. Please remember, right? And even you can see we have separated them with this two name, that is known as media layer, and other one is known as host layer. So up to hardware, you can see this is up to hardware part, so that's why it is known as medium layer. Network layer, router, till router is working over here. So you can see that till here it is known as media layer, because over here we are connected with wire, right? Over here we are connected with devices, and over here also we are connected up to devices. So that's why it is known as media layer. And then this is the software, the process to process communication, which end to end connection just now we have discussed, that is a transport layer. So from transport layer to the application, that is for host layer, right? Please remember this thing. Now this thing is talking about how data will be named when that it will reach to that layer, right? On the left hand side you will see. So in the application layer we will talk that information or that sequence of byte, that is known as data itself. Again, in presentation layer it is data only, in session layer it is data only. Now when we will move to the next layer, that is transport layer, then that data is known as segments, right? Then from transport layer to network layer, we are trying to add some more headers, and then this segment is called as packet, right? Then when it will move downward to from network layer, because we know that every layer is providing a service to its lower layer, right, in a top down approach. And upper layer, if we are moving on the receiving side from bottom up approach, right? So all in all means that each layer is providing service to the upper layer and the lower layer in that manner, right? So when that stream of data or you can say that stream of segments move further to the bottom layer, that is the network layer, then this network layer will add more information in it, like addressing, headers, right? So addressing is added, then that segment will be called as packet. Please remember this thing, right? Now after that, packet is further or you can say divided into frames. Now we are not saying that stream of zeros and ones that we are saying packet. It is not no more as a packet. Once it will reach to the data link layer, where one more header is added, that is known as MAC, right? Information. So now we are including that 48-bit address also, and then we are dividing that frame into a with special zeros, right? And separating that packet with some extra bytes. I will discuss this thing then when it will come in the unit, right? But yes, you have to understand that when that information is coming from network layer to the data link layer, then that information will called as a frames, right? So and finally, what we are sending the bits zeros and ones, right? So that zeros and ones will come in that from data link layer to the physical layer. And now in the physical layer, what we need some kind of modulation technique that will transmit the data, right? That zeros and ones could be able to transmit in the form of signals. So that part will come over here. That's why signal is written over here, right? So that zero, we cannot able to send zeros and one until unless we are making using of fiber optics. But most of the time you have seen we have an electrical cable around us, right? Like Cat6 is there an electrical cable, right? Or coaxial cables. So in that case, what we are doing, we are sending our digital data into an analog form, right? This is an analog form. So we need some kind of modulation technique, conversion technique, which will convert this digital data into analog form, and then we will through that wires, cables, right? Or through radio signal, because if it is a wireless, then we are making use of radio signals, right? Making use of spectrum, where we have a 2.4 gigahertz frequency, or what we called it ISM band, industry, science and medical ISM band, right? This band is also known as unlicensed frequency. Please remember this thing. And we are using in wireless technology. Now it depends that what is the medium through which we are transmitting. The medium is wired or wireless. Entire medium, that communication medium is divided into these two category, that is wired and wireless. Now wired is further segregated into fiber optics, coaxial cables, or normal cat6 cable, category 6 cable, right? Which talks about how we are going to transmit the signals, that electrical signals, right? Or analog signals, this digital data, right? And on the receiving side, again this signal will need to be converted into zeros and ones. Then again it will be transferred from bottom up approach, right? In this way. And you can see that the bits will be converted into frames, then frames are converted into packets, then it is converted into segments, and then it will take a representation form, and then finally the data is on your side. This is how the conversion is done and transmitted in a form of signals, right? Or radio signals. And then on the receiving side, again we have to turn it back to its original in the same sequence how we have converted, right? So that is a hierarchy. So, and that's why it is called as a layer structure reference model, right? So we are not using this seven. This was a idea which was initiated at the time when the Ethernet was introduced. And what we need a more efficient model, because it has too much of detailing. You can see 7 layers, which means too much of detailing. So this model was not successful at that time. Try to understand this thing, right? So what has happened then, this model was reduced to TCP IP model. You can understand over here that OSI reference model is now named, and the task is same, but we what we did is, over here you can see what we did. We combined the task of session layer, presentation layer, and application layer into application layer only, because there are too much of detailing and that leads to complexity, right? So after this model was not successful, that is 7-layer model was not successful. So in soon after that, what they moved to the TCP IP model, which talks about, okay, physical layer and data link layer is clubbed together, and now it is known as network interface. You can understand. So the task of data link layer will be done by over here, and physical layer will be done by over. So this is what we clubbed together, right? We clubbed the working role. Task will not reduce, but yes, we have clubbed together to reduce the number of layers. Now layers is reduced to something 1, 2, 3, and 4, right? In some books you will find it is also 5 because they have not clubbed the data link layer and physical layer, and they are showing this in this manner only. So physical layer, data link layer, network layer, transport layer, and these 3 layers are clubbed together and application layer. So in some book you will find 5 layer also. That is also okay, not a problem. And if you show in this manner, like physical layer and data link layer is clubbed together, and over here presentation layer and application layer and session layer is clubbed together into an application layer, which means that in TCP/IP model, application layer will perform the task of session layer, presentation layer, and application layer, right? So in this manner we reduce the layer structure, right? So this was there. And now I'm just closing here. Now this is a time for some quiz, because the chapter is over. Let me clear the screen for you. Now I will ask you few questions one by one, right? Stay with me. If you are not responding, you will be marked absent. So participant, yes, Deepa, turn on your mic. Yes, Deepa, are you there? Yes, Aishwarya. Yes, hurry up, please. Aishwarya, turn on your mic. Yes, Anmol. Anmol, are you there? Aradhna. Harpreet. Yes, turn on your mic.
Yes, sir.
Yes, Harpreet. Can you please read me the first question? The medium
Okay, sir.
is the physical path over which a dash is traveled. What is traveled?
Sir, message.
Yes, message is traveled. Very good, beta. Very good. Next, yes, Karan, 153 roll number. Yes, Karan, turn on your mic. Are you there? Yes. Mridul Sharma. Pawandeep Singh.
Yes, sir.
Yes. Who is there? Mridul. Mridul, second question is for you.
Yes.
Which is the correct option? Network failure is a measure of dash of a network.
Security.
Beta, secure network failure. Failure is talking about reliability. Reliable and reliable connection. Just yesterday only we discussed about TCP and UDP. So reliability, right? Right? Please remember this thing.
Okay,
Not an issue. Okay.
Okay, sir.
Okay. Next, who is there? Yes. Yes, Karan Ami 051. Turn on your mic. Karan, are you there? Yes, Sahil 313. Sahil. Ramandeep Mechanical 312. Yes, Pallavi. Turn on your mic. Yes, Rajveer Singh 061.
Yes, sir.
Yes, Rajveer. The third question is UDP is the protocol of which layer? Physical layer, network layer, transport layer, or data link layer?
Transport.
Very good. Very good. UDP is a
Sir, transport layer.
Yes, very good. UDP and TCP both are the protocol of transport layer. Very good. Right. Right. Any trouble
Yes, sir.
in any of the question you can ask, right? So we will have few more in the next class, and in that way, which let me cover this one for you people. So which packet moves from higher layer to the lower layer? Header is added or deleted? Yes, class, anyone? When packet is moving from higher layer to the lower layer. So from higher, that is top down approach. So in top down approach, what we are doing? We are adding or deleting the headers. We are adding, right? UDP stand for user datagram protocol. Please remember, right? So I'm just, we are left with only 1 minute. So I'm just taking not much time. Hub is a of that layer, physical layer. Hub is a device of